All right, so let me demonstrate how you test a claim about a proportion using the critical value method. Now, if you haven't already watched the 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 video about testing a claim using the p-value method, I would go back and watch that first because it lays the foundation. The critical value method is one that it's virtually the same thing. It it does one little twist at the end, but it does the same. It has the same purpose. We want to test the claim. Um, that being said, the p-value method is the one that gets used in real life research. And so the critical value method is just another way to accomplish the same thing. And in some ways, it's more straightforward. Let me show you how this works. So we're going to be using the same claim that we had before. And again, if you didn't watch that first video, go and watch it. The claim is that you know that uh, most people are comfortable, uh, or 50% of people are uncomfortable getting their packages delivered by drone. And so that's our null hypothesis. Our alternative hypothesis was that we thought uh, that more people, more than 50%, were uncomfortable. Okay, so you'll see that that is the same thing that we had before. So we go out and gather our data. We're using the exact same thing. N equals 1,009. And we found from our sample that we had 0.54. Okay, so that's all the same. We want to calculate our test statistic. And this is the same in both cases. It's still the z-score, 0.54 minus 0.50 over square root of 0.5 times 0.5 over 1009. Okay, and so that is exactly the same approach that we used before, and so we get a p or a z score of 2.54. I should also mention this: we are testing this claim at the significance level, just like before, of 0.05. So that's given to us at the beginning. Now here's where the critical value method is different than the p-value method. In the critical value method, you still have your bell curve. Okay? And in the center of the bell curve, you still have the claimed proportion, 0.50. Okay? But what we now want is we want to apply the critical value in this way. Based on the alpha level, we want a boundary so that the area to the right of that boundary is 0.05. This way. So we want it. This is the setup. We have an area in the right intel that is equal to 0.05, and so we want that boundary. All right. And so the question is, what is that z-score? This is the critical value that we talk about, and it is 1.645. There are several ways to find that. Perhaps the easiest way is to use the common critical values table, the same thing we used when we were finding confidence intervals on page A2 or on table A2. Anyway, so the z-score is 1.645. The area to the right of 1.645 is 0.05. So we set that all up, right? And we sometimes we'll even do that right here before we calculate the test statistic. Because here's what happens next. We calculate our test statistic, and it's 2.54. That means our test statistic is down here, right? Right in there, 2.54, right? Because this right here is 1.645. Our test statistic, here's the deal, our test statistic is in that critical shaded region. And the critical value method says if your test statistic lands beyond the critical value, beyond 1.645, then you are going to reject the null hypothesis. So again, what was the conclusion? If the test statistic is greater than well, I'm just going to put it this way, is in the critical region. Then we reject. And what's the critical region? It's the region beyond the critical value. Critical value was 1.645, beyond that green shaded region. Okay, so you notice we actually didn't find the area there. We just established the critical value that set up an area equal to the alpha, the significance level of 0.05, and determined whether our sample lived in that critical region or not. If it doesn't live in the critical region, then you will fail to reject.